right, so we're going to go to day 2 or 4.2b. And in this one, we're talking about designing experiments. Now, in designing experiments, there are certain verbiage that you want to know, such as control groups. When you're designing a proper experiment, you probably want to have a control group, which is used to prove a baseline data for comparison. So generally we have is treatments. One of the treatments will be a control group where nothing is imposed on that. And then you have some other variables in the treatment where you're going to check to see if there is a baseline or some sort of other effect on them. Now, sometimes when you apply treatments, you call what is known as blinding, all right? Blinding experiments. When you blind an experiment is when subjects, when it's single-blinded, and or experimenters, when it's double-blinded, who interact with the subjects are unaware of what treatments were assigned. So when you're just blinding those, you might receive a placebo. This is what's known as a placebo. Okay, the people think that they're getting some sort of control or some sort of treatment, but in fact they are not. They're receiving a placebo, and so you are determining through this blinded experiment what if the treatment actually does have an effect, or is it just known as the placebo effect when the fake treatment actually does work. Now, double-blinded is where nobody knows, so those that are interacting with the experiment, so the experimenters and the experimentees, the subjects, have no idea. That's known as double-blinded. Single-blinded is just the subjects have no idea if they're receiving a control group or the treatment group in the experiment itself. All right, so some keywords: control group, blinding, double-blinded or single-blinded, and then placebo effect is when they receive a fake treatment, but it works. 4 key principles when you're doing an experiment. The key thing is, first, you need to have comparison of 2 or more treatments. So there has to be comparison. Okay. The next thing is that it needs to be randomized. Same thing when you're doing surveying, you need to have a random assignment. Without random assignment, you don't have a true protocol experiment. The reason why you need a random assignment is because you use a chance process to assign treatments to the experimental unit, and so that everybody has a fair shake of receiving either the control group or the treatment. Well, technically, control group is a treatment, the various different treatments that you're imposing in the experiment. Make sure that their controls keep all other variables besides treatments constant. All right, so try to keep as many controls as possible so you can just isolate the explanatory variable. All right, to get that cause and effect. All right, we try to reduce as many confounding variables in our Turing experiments. And then finally, this is the most important thing: replication. Using enough experimental units to distinguish the differences. Because replication is where you do an experiment just on one person, but if you have several people or several things that you're experimenting, you can really test to see if there was several different ways that the different treatment actually, if it did or did not have an effect. So replication is having enough experimental units so you can distinguish differences in our values. All right, so here's the notes, okay, if you jot those down, and we're going to go to testing out and using check your understanding by going through an example now. So many utility companies have introduced programs to encourage energy conservation among their customers. An electric company considers placing small digital displays in households to show current electricity use and what the cost would be if this use continued for a month. Will displays reduce electricity use? Okay, so here's our displays. Here's really our explanatory variable, and we're going to see if it reduces a response variable of reducing electricity use. Okay, electricity use. I should box that in. All right, those different things. Okay, so one cheaper approach is to give customers a chart and information about monitoring their electricity use from their outside meter. Would this method work almost as well? The company decides to conduct an experiment using 60 households to compare these 2 approaches: display or chart. Display or chart. Okay, with a group of customers who receive information about energy consumption but no help in monitoring electricity use. Okay, but no help in monitoring electricity use. So with this, 2 approaches, and with a group of customers who did. So now explain why it is important to have control group that didn't get the display or the chart. Well, the reason why is because if you just gave them display and chart and it would reduce, there might not be much reduction in electricity use, and you would not know if the display or chart actually reduced electricity use. And so you're trying to really see, does either one of these actually reduce electricity use for one, and then which one is better, if any of them are better. And so there's two things. Does a display or chart reduce electricity use? So you're trying to determine a baseline from that. Okay. Need a baseline from the control group to determine, to compare if electricity use is reduced using displays or a chart. Okay, and that's what we're trying to really figure out. Do any of these actually work? Now describe how you randomly assign the treatments to 60 households. Okay, to 60 households. So this is what we would do. You would probably have to assign each one of these 60 participants a number. All right, and so now we're doing a randomly assignment, and so we would label all households a number 1 to 60. All right. Use a random number generator. All right. To select, all right, 20 unique numbers. These numbers will indicate who will be assigned. I'm going to say to control group first. Control group. So no chart or display. You can read this. Display. We will repeat the procedure. And select. I'm going to change this to a smaller font. It does the beginning, and select 20 unique numbers which will be assigned to display, and the remaining to chart. And that's what we do. Okay, so that's what we have a random assignment. So essentially we have these 60 people, and we're going to randomly assign, all right, first 20 to control, then another random assignment to displays, and then another, and the remaining whatever would be, which would actually does really, I guess we random assignment to charts, and that's how we would have our 60. So it'd be 20, 20, and 20, which makes up to 60 participants all being randomly assigned. What is the purpose of randomly assigning treatments in this context? To determine if if displays or charts affect electricity usage, right? Affect household, I'll just say household electricity usage. All right, electricity usage, specifically if it's reduced. Okay. If it's reduced, which one is possibly better if there's any difference. All right, determine displays rate effect if it's reduced. Which one is better? All right, if any. Does it have any effect? All right, and that's what we want to try to figure out. Now create an outline showing complete randomized design for this experiment. And so I already kind of did that already up here. And so I'm just going to bring this down. And so what's going to happen is you're going to have 20 random assignments for the control. All right, you're going to have 20 for display. And then for this, you're going to have these, give the treatments. Okay, so random assignment 20 for the control, display what, give the treatments. And then we're going to have our response. All right, we're going to collect data on electricity usage. And that's what we got right there. Okay, and that's what we have. Okay, and so that is what we have for experiments, and that's how we design it. So in each one of these, just use it and compare. And we're going to compare what they have there for our final thing. Okay, so 20 control, 20 display, 20 charts. Okay, I'll put 20 right there. Collect the data on electricity usage for each one of these treatment groups, and then we compare the results and see if there is any difference for that. Okay, and there we have it. Okay, and from that, I hope this helps you out on how we can use experiments, okay, and design experiments in order to get a cause and effect. All right. Hope this helps you out, and good luck and God bless in the rest of your problems.